Yeah, hello. Good afternoon, Ravi Shankar.
Good afternoon, sir.
Good afternoon. Ravi Shankar, first you try to introduce about yourself with your experience in the educational kind of qualification and the topic what you are going to take as a demo. Share your screen and start the demo.
Okay, sir. Myself Ravi Shankar Singh, physics faculty, and I have total 10 plus years of experience, and I have done BTech in mechanical engineering. I have taught in Patna, Nagpur, Agra, currently working in Nagpur, sir. And today's topic is concept of centripetal force. Yes, sir.
Fine. You can start demo.
Hello, sir. Is it visible a screen, sir?
Yeah, it's visible.
Okay, sir. Sir, I am starting a concept of centripetal force that is applicable in circular motion. So, centripetal force. Centripetal force, its definition is resultant of all forces acting toward the center of the circular path along which body is moving. So if we consider a circular path like this one, and suppose there is a stone system or a string block system, and this one is the center O and this is the position of the body. So centripetal force is always opposite to the radial direction. This one is the direction of radial direction or position of P with respect to O, and centripetal is always acting opposite to this radial direction. So if radial direction is from O to P, then centripetal force direction is from P to O. It means centripetal force have direction opposite to the direction of radial. And applications of it, suppose there is we are talking about a string system in which body is moving along horizontal circular path, and a string is connected with the stone. So if we draw the FBD of the body, then only forces acting on the body, that is acting along this line, is the tension force created by the string. So here centripetal force is provided by the tension, and so centripetal force here is T. And if suppose in the another cases, in horizontal circular motion with the other than a string, there are forces F and body is in circular motion. So in this particular case, if we draw the FBD of the body, then forces present on the body is tension toward the center and F is away from the center. and body is moving along the tangent. So in this particular case, center O is present here, so we have to take a resultant of all forces toward the center, that will be the centripetal one. So in this particular case, centripetal force is resultant of T and F, that is T minus F. So T minus F providing here the required centripetal force. In another case, if we consider a circular path, horizontal circular path, and body is somewhere here, and we have some forces like this one F1, this one force F2, and there is a string connected, and there is another force F3 here at an angle of theta. So in this particular case, what will be the centripetal force? Suppose here is center O, so centripetal force must be along this line. So we have to first of all break forces along line connecting body and the center O. So if we try to evaluate all the component along this line, one F2 is already present along this line, and F1 is perpendicular to this line, and F3 we will have a component of F3 cos theta away from the center, and there will be F3 sin theta perpendicular in perpendicular direction, and there will be a tension force T from body to the center. So in this particular case, we can see that resultant force, that may be that is the centripetal force, is T minus F2 plus F3 cos of theta.
Right. Suppose sir, consider a vehicle is moving on a banked road.
Okay, sir.
Having an angle of banking as a theta.
Okay, sir. Suppose if there is a,
so we need to find out the minimum speed of the vehicle that is to be maintained on the banked road.
Okay, sir. Suppose there is a banked road here, and angle of banking is given theta, and there is a vehicle here on the banked road, and that is moving out of the plane with a speed suppose v. So if we draw the FVD of the body, then we can see that there will be a normal force acting on the body along this line, and there will be a mg, and because we are talking about the minimum speed, so we know we have a relation with the r. If we are not talking about minima or maxima, so safe speed is under root tan theta z r. Z is constant, tan theta is also constant, so we can see that v is directly proportional to under root r. So if we try to decrease a speed of a particle, then there is tendency that r will decrease. So to ensure r less, body have to slide down, and if we have tendency of body sliding down, then there will be a friction force acting upward and along the plane, and if body is not a skidding, then friction will be a static one obviously, and body suppose moving along this circular path, so here will be the center. So we have to break the component of all forces along this particular line. So if we break the all component along this particular central line, so we can see that if this angle is theta, then from geometry we can see that this angle is also theta. So normal have a component toward the center, which is n sin theta, and because friction is also present, an angle of banking is given theta, so friction component, one component of friction is also present along this line, that is F s cos of theta, and mg is vertically downward on the body, fs sin theta vertically upward, fs sin theta vertically upward, and also n cos theta vertically upward. So we can see that from body to center, total resultant force, that is the centripetal force, is nothing but n sin theta minus fs of cos of theta. So this is the required centripetal force, and here in case of balancing we can say that fs sin theta plus n cos theta is balanced by mg. So we can write fs sin theta plus n cos of theta, and that is equals to mg. And we have to calculate the minimum speed, and we know we have a relation of centripetal force with a speed which is mb square over the radius, mb square over r is the radius of the circular path. So from here we can see that as a speed decreasing, we have as a speed decreasing, so how we can maintain minimum speed? So for the minimum speed we have to put friction maximum. So fs value, if fs value going to increase, then v going to decrease. So we can write here v. From this equation we can write v square equal to r over m and multiply by n of sin theta minus fs of cos of theta, and we have to calculate the v. So v can be what? V can be under root r over m n sin theta minus fs of cos theta. This is the general formula for v, but for the minimum v we have to take fs as a maximum one. So what can be the fs maxima? Obviously fs maxima is mu multiply mu s multiply by the normal. So from here we can write also fs as mu multiply normal sin theta plus n of cos theta equals to mg. So this equation have only the normal unknown. So putting here the normal and fs as mu multiply normal, we will get the required result. And required
Right.
Okay.
Suppose you have taken a string that is having a breaking strength of capital T, for example,
Okay.
capital T dash, okay,
Okay, sir.
and a mass of small m is attached to it lower end, and holding the other end you are rotating the block in a vertical circle.
Okay, sir.
Okay. So suppose if at the lowermost point
Ji.
the speed of the particle is 1.5 times to the minimum speed required to complete the vertical circle,
Okay, sir.
then at an angle of 30 degrees with the vertical, what is the tension in the string?
Tension in the string.
Yeah.
Okay, sir. So we know minimum speed required to go along circular is under root 5 gl. So initial speed u is 1.5 under root 5 gl, and we have to calculate the t. So if the O is the center and P is the body position, so we can write it as, we have to calculate the tension, and suppose a speed of the body is v. So first of all we have to calculate the speed v, because if here the in FBD tension is T, then mg will have two component, and one component will be mg cos of theta and other component will be mg sin theta, and body is moving along circular path. So here we can say that centripetal force is T minus mg cos of theta. and centripetal force we know is mv square over length of the string or radius of the circular path. So what can be the tension? Tension will be mg cos of theta plus mv square over L. So we can see that only unknown in this equation is V. Now for calculation of V, we have to use work energy theorem or law of conservation of energy. So I am going to use work energy theorem, and according to work energy theorem, final kinetic minus initial kinetic is the total work done. And here there are two forces acting on the body, one is tension and other is the mg. So we have to calculate work done by tension and work done by weight. Final kinetic energy is half mv square and initial kinetic energy is half mu square, where u is given 1.5 under root 5 gl. So also we can say that work done by tension is 0, because tension and motion both are perpendicular to each other always. So there is no displacement in the direction of tension, so work done is 0. And what will be the work done by mg? So we can see that initially mass is at this particular point, and after circular motion their angular position changes and body have this amount of vertical displacement. This length is L, total length is also L, this angle is theta, so this length will be L cos of theta. So what will be the height gained or displacement gained by body? That is L minus L cos of theta. So displacement is getting L multiply 1 minus cos of theta, and so we can write that work done by mg is what? Mg is vertically downward and displacement is upward, so work done is negative, so negative mg and displacement magnitude is L1 minus cos of theta, and half mv square, where v is unknown, and half m u is already given 1.5 under root 5 gl. So we have to square this amount 1.5 under root 5 gl, and so we getting mass getting cancel out, and v square equals to 1.5 square will be 2.25 multiply 5 gl, and there will be plus 2 gl1 minus cos of theta, and so v will be the square root of this amount.
Like, is there any other topic like where you are confident enough from the class 11th and 12th?
Yes sir.
And are there any other topics like which you have not much covered from the last few years of teaching experience?
Yes sir, I taught mainly all over the physics, so I can take any of the topic.
Okay.
Yes sir.
Suppose like you have taken, let's take a question from thermodynamics.
Okay sir.
Okay. Suppose you have taken some ideal gas.
Okay sir.
Okay. And the ideal gas pressure and volume graph is plotted for a process.
Okay.
Okay. And then that the graph for the process is look like a y is equal to minus mx plus c. Okay.
Y
So
equals
now-
to?
Minus mx plus c.
Okay. First of all write equation y equals to mx minus c. Okay sir.
Minus mx plus c.
Minus mx plus c. Okay sir.
So suppose if I go from one point on the graph to the another point on the graph,
Okay.
that is from a point on the y-axis to the point on the x-axis. So how will be the temperature of the gas changes?
Okay. Whether it will increase or decrease. I have.
Yeah.
Okay sir. So in PV diagram, we can draw the isothermal curves. Concept is, in case of PV diagram, isothermal curve is like this one, because PV in, if isothermal condition temperature constant, then PV is also constant. So P is inversely proportional to V. So there will be rectangular hyperbolic parallel curve for different isotherms. So, and this will represent different temperature T1, T2, T3, T4, and here T1 is greater than T2 is greater than T3 is greater than T4. So if we try to draw isothermal curves in this particular graph, so suppose this one is the PV diagram and we have drawn different isotherms like this one, and we have drawn a straight line like this one, so we can see that at this particular point temperature is T1, at this particular point temperature is T2, at this particular point temperature is T3, and at this particular point temperature is T4, and already mentioned that T1 is greater than T2 greater than T3. So we can say that temperature going to decrease, and it may also temperature is going to decrease here. Yes sir.
Okay, so what do you call this type of process where we get a straight line graph?
If we have a straight line graph, then we have to tell about the process. So suppose if equation is y equals to minus mx plus c type, then in place of y there is p, and minus m x is v, and there is some constant c. So we have ideal gas equation PV equals to nRT. So if we put the pressure here, so we can write this as minus mv plus c and multiplying by v, that is equals to nRT, and so we can write this as minus mv square plus cv equals to nRT. So what we can say that if temperature is increasing, then volume is increasing, and if we convert this in terms of pressure, then what can be the relation? We can write V as P plus C over minus M, and that is equals to nRT, and so we can write it as P square plus PC equals to minus M nRT. So from here we can see that as temperature increases, pressure going to decrease. So
Right.
yes sir.
Suppose say you have taken some 10 moles of oxygen gas, ideal gas.
10 moles of oxygen gas.
Yes.
Okay sir.
That is taken some adiabatic nature of container having a constant volume.
Okay sir.
And at a given temperature, no, not an adiabatic. Take it as a constant volume system. Don't take the adiabatic.
Okay sir.
At a given temperature,
Okay.
10 moles out of the 10 moles of oxygen gas, suppose 2 moles of oxygen is dissociated into the atomic gas.
Okay sir.
Okay, on supplying of the heat energy
Okay sir.
at a constant temperature.
Okay sir.
So the question is, what is the amount of heat energy supplied?
Okay sir. If volume is constant, volume is constant sir, always?
Yeah, volume is constant.
Okay, sir.
Temperature is also constant.
Okay sir. If volume is constant, so if we apply PV equals to nRT, temperature is constant and volume is constant, and if we use the thermodynamic equations, Q equals to W plus delta U, so there is no delta U here, so we can say that work done is equals to the heat supplied. And I am changing pace sir, taking some time in changing pace.
That's no issues. You're from which location, sir?
Sir, currently working in Nagpur, sir,
Nagpur.
and I related to Bihar.
Okay.
Yes, sir. So initially number of mole is given 10, and gases is oxygen, and so heat supplied must be equals to the work done. And what may be the work done? And work done in any process will be PdV or nRdt, PdV, and there is no relation given in between P and V. So how we can write it as temperature is constant also, so there may be delta U, because delta U have the relation F by 2 nR delta T, but delta T is constant, so there cannot be delta U. So how it is possible that we can provide heat? So heat goes into internal energy, because volume is constant. So we can write it as F by 2 P2, N may be different, but temperature is still constant. F by 2 P2 V2 minus P1 V1. PV is nRT. F by 2 PV is nRT2, but still temperature is not given. Temperature is constant. Okay, maybe temperature constant but N is different, so delta U may be possible. Delta U may be F by 2 nRT2 minus F by 2 nRT1, and because temperature is constant, so we can write F by 2 F1 by 2 N1 R minus F2 over 2 N2 R, and temperature is constant. And because volume is constant, so we can say that delta U is the heat supplied. So we have to use this processor, and we have to calculate number of moles, and now the mixture degree of freedom, and initial number of moles and initial degree of freedom. So we have to apply this concept.
Right. And like you said, you are comfortable in all class 7th and 12th, right?
Yes, sir.
Like from how many years you are teaching?
Sir, mainly in JEE NEET I have 7+ years experience, and total experience is 10+.
So right, sir, it was nice session with you.
Okay,
I wish
sir.
you all the very best.
Nice to meet you, sir. Thank you.
Nice. Thank you.
Thank you, sir. देखो ये